Hello students, myself Sarama Malik Das, Assistant Professor of Gargi Memorial Institute of Technology. In my previous lecture, I discussed about the double integrals, and today I discuss about the transformation of double integrals. Okay, here let the variables x and y are transformed to the variables u and v with the help of the transformation equation x equal to function of uv and y is equals to, this is also a function of uv or g of uv. Okay, then the region are in xy plane of the integral double integration over the region R, capital F of xy dx dy is mapped to the region R dash in UV plane in plane. Then we have double integration over the region R f of xy dx dy. This is equivalence to double integration over the region R dash function capital G of uv and Jacobian of del of xy by del of uv du dv, where g of uv, this is equals to function of f of uv and g of uv, means capital F of xy. Okay, and del xy by del of uv, this is the Jacobian. Okay, so this is the transformation of double integrals. Now we illustrate some examples. Evaluate double integration over the region R x square plus y square dx dy, where R is bounded by x square minus y square is equals to 1, x square minus y square is equals to 9, xy is equals to 2 and xy is equals to 4. Okay, so this is our question. Now to solve this problem, first we transform this double integral from xy plane to uv plane. Okay, so first we draw the figure. Looking at the curve surrounding the region R, we give the transformation x square minus y square is equals to u and xy is equals to v. Okay, so first we draw the xy plane. This is x square minus y square is equals to 1. And this is x square minus y square is equals to 9. Okay. This is xy is equals to 2. And this is xy is equals to 4. Okay. So this is our bounded region capital R. Okay. In xy plane. And after converting, this is xy plane. After converting to UV plane, this will be say V is equals to 2 it is 2 it is 4 and rest U is equals to 1. This is U is equals to 1. This is U is equals to, sorry, this is 9. 9 R dashed. V is equals to 4 and V is equals to 2. So this is our region. Okay, this is UV plane. Clear? So this is our main original region and this is the transform region. Clear? So we see here the curves x square minus y square is equals to 1 and x square minus y square is equals to 9 in xy plane transform to u is equals to 1 and u is equals to 9 in UV plane and xy is equals to 2, xy is equals to 4 transforms to v is equals to 2 and v is equals to 4 in UV plane. Okay, so the complicated region complicated region in xy plane, that is capital R, is transformed to a simply rectangular region R dash in UV plane. Okay, so now we find the del of UV by del of xy and the Jacobian. This is equals to, we know the formula, del u del x, del u del y, del v del x, del v del y. This is the formula of Jacobian, and here x square minus y square is equals to u. Okay, x square minus y square is equals to u. So when we find del u del x, this value is 2x, and del u del y is equals to minus 2y, and del v del x, this is equals to y, and this is x. Okay, so this means 2 into x square plus y square. Okay, so del xy del uv, this is equals to 1 by 2 into x square plus y square. Okay, and this can be written as 1 by 2 into root over of x square minus y square whole square plus 4x square y square. Okay, that is equal to 1 by 2 into root over of u square plus 4v square, as x square minus y square is equals to u and xy is equals to v. So double integration over the region R, x square plus y square dx dy, this is equals to double integration over the region R dash, x square plus y square means this value. So this is root over of u square plus 4v square, and del of xy by del of uv dx du dv dv. Okay, so this is equals to double integration over the region R dash. Okay, sorry, we put here the integration value limit, that is u is equals to 1 to 9, v is equals to 2 to 4, root over of u square plus 4v square into 1 by 2 into root over of u square plus 4v square into du dv, that is equals to half of integration of u is equals to 1 to 9, v is equals to 2 to 4, u du dv. Okay, all are cancelled here. So 1 by 2 integration of u is equals to 1 to 9. If we integrate with respect to v, this will be v 2 to 4 du, that is half of u is equals to 1 to 9, 4 minus 2 into du, that is half of u is equals to 1 to 9 2 du, that is u 1 to 9, 9 minus 1, that is equals to 8. So this is our answer. Okay, now we illustrate another example. Evaluate integration 0 to a into root over of a square minus y square integration 0 to a and integration 0 to root over of a square minus y square. x square plus y square dy dx, changing to polar coordinate. Okay, so for this, in xy plane, the region of integration r is 0 less than is equals to y less than is equals to a, and 0 less than is equals to x less than is equals to root over of a square minus y square. As it is a function of y, so it is the must be the limit of x. Okay, so that means 0 less than is equals to y less than is equals to a, and x square less than is equals to a square minus y square. That means 0 less than is equals to y less than is equals to a, and x square plus y square less than is equals to a square. Okay, so there is a circle. To change to polar coordinate, system, we put, okay, so we convert here the circle of xy plane into the polar coordinate system. So what we put here? Do you know what we put here? This is our circle. Okay, so we put here x equal to r cos theta and y is equals to r sin theta. Clear? So from here we get x square plus y square is equals to r square, and tan theta is equals to y by x. Okay, now the here this is the region capital R. Okay, and in that region, for any point having polar coordinate r theta, we see in the region R, region capital R, uh, for any point having polar coordinate r theta, we see that 0 less than is equals to r less than is equals to a. Okay, and which is the as the radius of the circle is a. Okay, and theta varies from 0 to pi by 2. So the point can lie in the first quadrant of the xy plane. Clear? Then So r theta plane, that means in polar plane the transform region r dash is 0 less than is equals to theta less than is equals to pi by 2 and 0 less than is equals to r less than is equals to a. Okay, and the Jacobian del xy by del r theta, this is equals to del x del r del x del theta del y del r del y del theta. This is equal to, so x equal to r cos theta, that means del x del r is equals to cos theta and del x del theta is equals to minus r sin theta. Del y del r, this is sin theta and this is r cos theta. So from here we get r cos square theta plus r sin square theta, that is equals to r. Okay, so from the integration which is given here, 0 to a, double integration 0 to a and 0 to root over of a square minus y square, x square plus y square dy dx. This will change to integration theta is equals to 0 to pi by 2, r is equals to 0 to a, r square cos square theta plus r square sin square theta into the Jacobian dr d theta, that is equals to theta is equals to 0 to pi by 2, r is equals to 0 to a, this is r square, this is r dr d theta, where r is greater than 0. Okay, so from here we get theta is equals to 0 to pi by 2, r is equals to 0 to a, r cube dr d theta, that is theta is equals to 0 to pi by 2 integrated with respect to r, that means r to the power 4 by 4, 0 to a d theta, which is equivalent to d theta. That means a to the power 4 by 4 pi by 2 0, which is a to the power 4 by 4 into pi by 2, that means pi into a to the power 4 by 8. So this is our answer. Okay, so in our next class we discuss about the application of double integral.